Hello, today I am going to talk about the logic gates and their experiment with IC. The logic gates basically three types: AND gate, OR gate and NOT gate. The AND gate, which we easily draw like this. This is two inputs dot or product, like the two input like X, Y and Z. This is X, this is Y and this is Z. So if we put here the inputs and this is output, so dot product is like X dot Y is Z. So 0, if we put one side 0 and the another side is 1, so normally this is a Boolean algebra. So we get the output 0 and this is the AND gate. If we put 1 with 0, we also get 0, but if we put 1 and 1 and this comes 1, so if we here put 1 and 1, we should get 1, and any of them if 0, then the output will be 0, and this is the AND gate. Also here comes the OR gate. So if we draw a OR gate, it looks like this. So here is X, here is Y and here is Z. So it is normally plus or summation, like we put 0 here and put 1, we should get 1, and if we put 0 0, we should get 0, and here is the sign. And if we put 1 plus 1, we should get 1 plus 0 1, and this is the OR gate. These are the basics. NOT gate is just a inverter. Like if we give a one input one output, if we give a input X, this should be X naught or X bar. So if we give X, the output will be X naught. If we put 0, the output will be 1, and if we put 1, the output will be 0. These are the basic gates. To experiment these gates, we will use the ICs. First we use the AND gate. We check the AND gate and the IC will be 74HC08. Also we will use for OR gate 74HC32, and for NOT gate 74HC04. So for AND gate, this is 74HC08. It looks like this. This is for NOT gate 7404. You can see 74HC04. We call it 7404. And also this is 74HC32. This is for OR gate. There is also another gates, the NAND gate, NOR gate. These have also ICs. I will mention the IC names at the end of this video. So here is a breadboard, and we already arranged the circuit. This is a simple circuit. We see This is 74HC08, and we can manage this with two jumpers with both side, minus to minus and plus to plus to extend the line. We will give 5V power for the IC. Normally this chip, it looks like this in diagram. So in the chip we see a dot above, and from this dot side the pin number 1 starts, and 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Now in this chip we see the gates how arranged. First of all we see the 1 2 and 3, and there is an AND gate, and also there is an AND gate. Total 4 AND gates in this IC. The IC's 14 and 7 pin is not for the gates, it's just for the ground and power. Pin number 7 is for ground and pin number 14 is for power. Here is the breadboard, and we put 74HC08 AND gate IC. This is pin 1 and this is pin 7. You can see the round circle here. Not this is, which is close to the pin. This is 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and we put the power with this jumper. You see this extends with this jumper, and here now there is the ground pin 7, and I put negative ground, and this is pin 3 2 1. Here will be one input, another input, and this is output. We see from this diagram 1 is input, 2 is input, and 3 is output. Now these resistors are 220 ohms to limit the currents for the bulbs. Now we put the bulbs. Here is for pin 1, here is for pin 2. See how I put the bulbs. Here is for output. Now carefully see the breadboard arrangement. We see the input 1 and 2 is grounded, so the input is already 0, doing 0. So what will be the output? So there is no output, as we see the AND gate where 0 and 0, there should be no output. The both of the input is 0, set 0, so our output is 0. Now if we change one of the input 0 to 1, so what happens? Let's check. So one of the LED is light, so pin 2 is now on 1 and pin 1 is 0, and the output is 0 1 0 0. Also if we put this, and this should be grounded, and this is positive. Now the output is 0, so we say 0 1 or 1 0 is 0. This is the operation of AND gate. If we put both of the input is 1, now the output is 1. We see the red LED is now on. We will also test the other gates like NOT gate and OR gate. Now we are going to test the OR gate. We just simply replace the IC with 74HC32. This is the OR gate IC. So we are replacing the IC with 74HC32 in the same place. Before experimenting these logic gates ICs, you should know about the breadboard's fundamentals. These are the bus line, and these are the columns. The bus line just for power plus and minus. Now we replaced the IC with 74HC32. Now I am putting the both of them is 1. As you see, the both of the LED or the input is 1, so output is 1. What is happening? So we go here. Now if we check the OR gate operation, so X, Y and Z, this is if we put 0 here with 0, so this operation is X plus Y. So 0 plus 0 is 0, 1 plus 0 is 1, and 0 plus 1 equal 1. Also 1 plus 1 equal 1. So we got this. Now if we change one input to 0, the output is 1. So if we change both of the input to 0, so output is 0. And this is the operation. And this IC is 74HC32. You should check for this IC's datasheet on the internet, and you will get more information about this IC. And another IC is 7404, and this has just only one input and one output. We will replace this IC with 7404 in the same place. 74HC04. Okay, there is little bit changing. For this 74HC04 NOT gate, we will get one input and one output. So the diagram will be like this. So this is for pin 14, this is for pin 7. 1, 2, 3, 4, 5, 6, 7. Another is 8, 9, 10, 11, 12, 13 and 14. So there is 6 NOT gate in this chip. Look this, like this, and like this, and this is for ground. So this is pin 1, 2, sorry, 2. We will check just pin 1 and 2. So here, if we put 0 to the input, the output will be 1, and if we put 1 to the input, the output will be 0. And this is the 74HC04 for NOT gate operation. And there is a NOT, and this operation is x y. It should be x dot y, but the output will be x dot y not, the opposite of x dot y. So if we put 0 and 1, we should get 0 into 1 equal 0 as AND gate. But for NAND gate we will get 1, like 0 into 1 equals 0, but its opposite is 1. Then 1 into 0 equals 0, but it's 1. 0 into 0, we should get 0, but it's 1. And 1 into 1, we will get, normally we should get 1, but we will get 0 for this input. Now I'm going to check the IC, and this is 74HC00. So previously we used for AND gate and OR gate 74HC32 and 74HC08. The pin is same as 74HC00. 1, 2 and 3 is for NAND gate. Zero into 1, 1. So we get the output 1 into 0, 1. If we check another side, if both input is 0, we also get the output. But if both input is 1, the output is 0. And this is the NAND gate. The rest of the gates, XOR gate, NAND gate and NOR gate, which I have not at this moment. The ICs are 74HC86 for XOR gate. I see that 74HC86, it is for XOR gate, and 74HC00 is for NAND gate. I already used it. And 74HC02 is NOR gate. Thanks for watching the video. Please subscribe to my channel. In the next video I will show more complex Boolean algebra and logic diagram mathematics.